Hey .NET Conference attendees, Rick LaPlante from Mobilize.net here. In this video we're going to talk about using the .NET Compilation API, also known as Roslyn, to improve the readability and maintainability of your source code by implementing some custom attributes. The functionality described by your custom attribute can be as simple as logging or as complex or intricate as a state management infrastructure. The basic pattern for implementing an attribute is as simple as find and replace. We find all of the places in the source code where we want to apply the attribute, and then we update the source code. Probably the most important thing to remember when dealing with Roslyn is that you're not dealing with text strings, you're dealing with parse trees. And that means we're going to end up visiting every node in the tree, so our search is implemented using the visitor pattern. In order to implement our search using the visitor pattern, we actually need to understand the structure of the parse trees. And to do that, Visual Studio comes with a really nice tool in a window called the Syntax Visualizer. So if we go ahead and open up the Syntax Visualizer and take a look at our demo source, you'll notice that if I put, for instance, my cursor over the class, the Syntax Visualizer actually shows me what the parse tree looks like, where we have a class with the class definition, methods with method definition, declarations. You'll notice both of them in there, as well as our attribute list. So with that, we can go ahead and start writing our search or find function. Implementing search methods is actually quite easy using Roslyn because we can inherit from C# syntax rewriter. Inheriting from C# syntax rewriter actually provides us a visitor pattern for every type of syntax in the tree. This code here gets called for every node in the tree that is a method declaration using the visitor pattern. And when we find a node that actually is a method declaration, we can check and see if it's decorated with our attribute. This code here actually does the check to see if it's decorated with our attribute, which is called myAttrib. So first we remove the attribute node, and then we add the code at the end of the method body. Now we just need to invoke the visitor pattern. To do that, I've got a simple C# program here that reads in the file that we're interested in, creates an instance of our method rewriter, executes the visitor pattern on it, and then rewrites the file out. And so we should see this file change in Visual Studio once we run this program. So let's go ahead and run the application. And you'll notice that when it finishes, it tells us that one of the source code files has changed. And there it is. You'll notice the attribute's gone, and our console write line has been added to the source code. So now that we've taken a look at a simple implementation, maybe we should take a look at some more real-world ones. So we use this approach at Mobilize.net when we convert rich desktop applications into web applications to ensure that the resulting code is maintainable and readable. So here's a simple WinForms application that basically puts up a form and handles a single click event. If we look at the same source code post-migration, you'll notice they look almost the same. In fact, the only change in this case is our observable attribute on the class definition. This is the code that the developer has to interact with. It's quite readable, easily maintainable. As you can imagine, there's a bunch of hard problems that need to be dealt with here. Using attributes allows us to keep the code that the user sees clean and readable while dealing with those issues. Just like in our example, at compile time, that attribute gets resolved into code generated into a new source file. Using these attributes allows us to hide all of this infrastructure code. At Mobilize.net, we get a lot of value out of using Roslyn and attributes, and I think that you guys will too.